Chapter 9, Input Modeling, Part 3. The first method here we have for distribution identification, or somehow a method for test of goodness of fit, is QQ plot. So here we assume that we have a sample of random variables, a sample of data by, we should the sample of data by xi, so we have n data, and now we are going to assume that a distribution with a CDF of f is a good choice for this sample of data. So then we sort the sample of data in ascending order and show them by y. So we'll have y, y2 up to yn. Okay. So the QQ plot, or quantile plot, is based on the fact that yj is an estimate of this quantile of x, j minus half over n. So the existence of half here, instead of having j over n, is just because of having a limited size of sample. If we have infinite data here, then this half will have no impact on our calculations, right? So yeah, it's just for the accuracy purpose here. So yeah, here we assume that yj is an estimate for f inverse of j minus half over n. Okay, so then we'll plot yj versus f inverse j minus half over n, which is called QQ plot. And if the CDF of f, the distribution that we have chosen, is a good choice for this data set, then this plot should be approximately a straight line. Okay, so, and if the assumed distribution is inappropriate, then the points deviate from the straight line. Okay, so let's have a discussion here for QQ plot. The observed values will never fall exactly on a straight line. Yes, if we do have infinite number of sample data, then yes, they will exactly fall on the straight line. But since we have a limited number of data from as a sample from that distribution, so we shouldn't expect to see that all the numbers are exactly falling on a straight line. And the observed values are not independent here, since they are ranked, right? And the variance of the extremes, the tail of the distribution, are much higher than the middle. So because of that, the linearity of the points in the middle of the plot is more important than at the extremes. Okay, and the last thing here is this: the QQ plot is somehow an informal way and a visual, let's say, test to fit a visual method to test the fit, the goodness of fit, but it's not formal, so we can't rely on this method and say, yes, this distribution is a good fit for our data set. So if we have some candidates, some decisions as candidates for our data set, then we can somehow filter and narrow our choices by having a Q plot. But after that, we need to consider the chi-square test or KS test as the formal methods to test the goodness of fit. The chi-square test, so you are familiar with this method. It's exactly the same as the one that we had in previous chapter. So yeah, and chi-square test is one of the formal methods to test the goodness of fit of a distribution on a data set. Okay, so here again, same as before, we arrange the sample of n observations into a set of k class intervals. So at first we consider k class of intervals, and then we calculate this statistics as the chi-square statistic. And then, so yeah, OI is the number of observed frequency in the Earth interval, and EI is the expected frequency. So we can obtain the EI, expected frequency at interval I by multiplying the sample size by PI. So PI is the probability of that class interval. Okay. So here we assume that the chi-square, that statistic approximately follows the chi-square distribution with k minus s minus 1 degrees of freedom. So here k is the number of class intervals and s is the number of parameters estimated by sample statistics. For example, if we are assuming a normal distribution, so we have two parameters, right? Mu and standard deviation. So here S will be 2. But if it's about exponential distribution, so we have just one parameter, which is lambda. So S will be 1 here. Okay, and this is the hypothesis test here. Null hypothesis H0, the random variable X conforms to the approximated distribution, and H1, the random variable X does not confirm the approximate distribution. Okay, so the critical value of chi-square with a level of significance alpha and degrees of freedom of k minus s minus 1 can be found in table A6. And then if our statistic is greater than this critical value, we will reject H0. Other than that, we fail to reject H0. So, and one note here, any EI less than 5, if we do have this, then combine the Rth interval to its adjacent class interval in order to have EI be greater than 5. Okay. Here we have an example 9.17 from the textbook for chi-square test, and it's about a Poisson distribution, so it's a discrete distribution, right? And since in a Poisson distribution we have just one parameter alpha, so S becomes 1 here, and the k is the number of intervals, and so the degrees of freedom for this test becomes k minus s minus 1. Okay, and the alpha here, the significance level is assumed to be 5%. So I will go through the detail of this example in Excel in our live session this week. Okay, so if we are going to test in continuous distribution other than discrete one, then instead of having the intervals with equal width, we can consider the intervals with equal probability. Okay, and therefore the pi becomes 1 over k. So if we have k interval, then the probability for each interval will be 1 over k. So we'll have k intervals with the same probability. Okay, then recommendation for k here comes from this assumption that we assume that we need to have EI to be greater than or equal to 5, right? So by having this, then we can say k should be less than or equal to n divided by 5. So n is the sample size here. So for example, if the sample size is 20, then it's recommended to do not use the chi-square test because the sample is not large enough to be done by chi-square test. So if we have 50 as sample size, so any number for between 5 to 10 would be good for the chi-square test, and so on. Okay. So here we have another example 9.18 for a continuous distribution, and it's an exponential distribution. So Yeah, I mean, since it's again exponential, we do have just one parameter, so S is 1, alpha is 5% here, and again, I'll show the details of this example in Excel in our live session this week. Okay. The second formal method that we have for goodness of fit is Kolmogorov-Smirnov or KS test here. So in this method, instead of estimating the parameters of the distribution, we transform the distribution into a uniform distribution, and then we can apply the KS test method here. So for example, assume that we have 50 interval times in minutes, which are collected over 100-minute interval. Okay, and so we do have the data here for 50 interval times. So the interval times t1, t2, and so on are exponentially distributed. We know this, right? And this is our null hypothesis here. And we want to see if the exponential distribution is a good fit for our data or not. So when the interval times are exponentially distributed, then the arrival times large T1, T2, and so on, they are uniformly distributed over 0 to T, and T here is 100. Okay, so here if we calculate the arrival times by having the inter-arrival times, and then if we sort the arrival times in ascending order, and then for each I, let's say we have the CDF, the F, as Ti divided by T, and on the other hand, we have I over N, and also I minus 1 over N, right? So by having these values, we can apply the KS method, and if we fail to reject the null hypothesis by this method, this means that the arrival times are based on uniform distribution, and it means that the inter-arrival times are based on exponential distribution. Okay, so again, I'll show the detail of this example in our live session this week. Okay, so we are done on this chapter, and in this chapter we'll learn the methods and techniques in order to model the input data for a simulation model. So here we fit distribution for our data, and then we can test if that fit is good enough in order to assume that distribution for the variable that we have in our simulation model. And also in this week and in lab session, you'll see how you can do this in Arena. So Arena has a module to fit distributions, and it's called Input Analyzer. So you will see in this lab session that how you can do this through Arena. Okay, so and that's it. Thank you.